That's an interesting set of instructions here in number 26. We're supposed to look back and find the domain. Remember the domain, or highlight the x-axis where it represents the domain. The domain is x values. That's why we're shading the x-axis. X values that make sense, and I've used the analogy of using some sort of crushing device. I specifically referenced the first Terminator movie where they squash the Terminator and that's what finally stops him. But this, if you can squash this thing, and where would this graph show up on where would the remnants of this graph show up on the x-axis? Well, if you squash it, this dot's going to sit right up there, and all the rest of the line is just going to be sitting flat on the line. So in terms of shading, it's going to start there, and it's going to kind of shade that direction. Now this one's interesting. Very specifically, it does not hit at this. You cannot plug in a -2 into this equation because it makes this have a 0 in the denominator. So there is not going to be something here, but in terms of the shading, everything from this one and on in that direction forever, and this way on this direction forever is going to be included. So really in the domain of this one, it's everything except -2. This one here, if we use the crusher, yeah, it looks like this is going strictly up and strictly down, but it is going up at an angle. So if you use the crusher, it's going to bend this thing, and it's going to end up bending it over so that you have an arrow going that way forever. There are no limitations to the domain with a cubic. So it's basically just shaded all the way along the x-axis. That's true of any cubic. And what's also true of any square root, it's going to have a definite starting point, and it's going to go one direction or the other. And then back to here, open circle, shaded in all directions. And in 27 through 31, we're supposed to use some sort of mathematical notation to identify what's going on here. This one's relatively simple. We can say that this is x is greater than or equal to 0. Here, x is not equal to -2. Now, the technical notation would be all values of x such that x is not equal to -2. In set notation, that would be kind of the technical way of doing it. But if you put x is not equal to -2, you'd probably want to make sure you're saying all values of x such that x is not equal to -2. All real numbers, you can do that. But a quick way of doing that is a capital R with sort of a little flair to it, a little fun added. So if you simply put that means all real numbers. Set notation obviously would go along nicely with that, but all real numbers is acceptable. In this case here, it's starting at -3 and going over x is greater than or equal to -3, and here x is not equal to x such that x is not equal to +2.